Good morning, my dear students. Now today in the Boolean logic lesson, this is the last class of this Boolean logic lesson. I am going to discuss few questions with you. Now as it is given in your book, x plus xy is equal to x. This is the absorption law, and you have to remember all the laws first of all. This is the absorption law, and in this absorption law you have to prove this, that this is equal to this with the help of truth table. So you have to draw this x and y table, and 0 0 you can see easily. This is the two input equation, two variable input equation. So x this is first and y this is second. So four values will be there: 0 0 1 1 1, and this is 0 1 0 1. So then we calculate this x and y, means if any false is there, means 0 is there, so you will give 0, and x plus xy, as we have calculated this xy, so it's easy to add this x in this. So add this x plus xy. So in addition, in OR logic, we know that if any one is there in the row, then we will give 1. So in this you can see x and xy both are 0, so we will give 0. In this you can see both are 0, you can give 0. In this you can see 1 is here, so 1, and in this both are 1, so you will give 1. Now you can see here both are equal. So this is the absorption law, that this is equal to this. So that's why we are telling x plus xy is equal to x. I hope this is clear to you. This is the question in your book also, it is given. Now in Boolean algebra, this is question number 2. In Boolean algebra, verify using the truth table, and this is the equation given here. X plus y, this is bar, you can write bar and dash, both are same, and x bar y bar, this we have to prove. So you can see this is two variable equation, this is two variable equation, and x and y, so 0 0 1 and 1, 0 1 0 1. First we have to calculate x plus y. X plus y means this is OR logic, if any one is there then you have to give 1. So it is 0 1 1 1. Now x plus y bar, so x plus y bar means just reverse it, 1 0 0 0. So with this we have calculated. Now come here, so x bar and y bar, so both of these we will calculate first. So x bar means 1 1 0 0, and y bar means 1 0 1 0, and then after x bar y bar we have to find. So in this what we will do, if both are means just 1, then we will give 1, or if both are means any 0 is there, then we will give 0. This is the multiplication logic, means if both are 1s then we will give 1, if any 0 then we will give 0. So you can see here both are 1 1, here 1 0 0 1 0 0 2 0 0. Now you can see this column and this column, x plus y bar, this is x bar y bar. You can see this 1 0 0 and 1 0 0, both are same. So this was the second question, and in this kind of questions you will get in your exam, that prove this. So you have to draw the table and you have to show the answer like this. Now the question number 3, give truth table for the Boolean expression x plus y bar, x plus y bar, one more bracket and then bar. So you know this, that finally x plus y will come, because if two bars are there, then then both will be cancelled. So in this we have to give the truth table, so we will draw the answer. This is the true variable equation. So x and y 0 0 1 1, 0 1 0 1. Now x plus y we have to find. So if any one is there, then we will give 1. Then x plus y dash we will find, means simply reverse it, 1 0 0 0, and then finally x plus y dash and dash, double dash. So reverse this, 0 1 1 1. Now again you can see this you got. So as I was telling, if two bars are there, then both will be cancelled. So in this you can see this column and this column both are same. In this bar has been removed because two bars are there. So x plus y you got 0 1 1 1, and in this also 0 1 1 1. That's why we are saying this is equal to x plus y. If two bars are there, then both will be removed. Now dear students, now question number 4, using truth table prove that AB plus BC plus CA bar is equal to AB plus CA bar. In this you have to count the number of variables A, B and C. So 3 variable it is, A, B and C. For 3 variables you know that 8 input conditions will be there. So first I am drawing this so that values should be separated. One, 2, 3, 4, 5, 6, 7. This is 8. First is AB, and A bar also we want. So first I am calculating A bar here. So 0 0 0 0 and 1 1 1 1, 0 0 1 1, 0 0 1 1, 0 1 0 1 0 1 0 1. Now A bar means 1 1 1 1 0 0 0 0. Then after AB, so AB means multiply. If any 0 is there, then you have to give 0. So 0 0 0 0 0 0 1 and 1. Then after BC means these two. If any 0 is there, then you have to give 0. So 0 in both you can see 0. Here you can see this is 0. Here 1, here 0, here 0, here 0, and here 1. Then after C A bar, so C it is and A bar it is, so any one is 0, then we will give 0. So this is 0 1 0 1 0 0 0 0. Then after we have to add all these three, means here I am writing AB plus BC plus CA bar. So this was the first left hand side. So AB, BC, CA bar, all these three columns we will add. In addition, what is the logic? If any one is there, then we will give 1. So it is 0, here 1, here 0, here 1, here 0, here 0, here 1 and here 1. Then after this part, AB is already calculated, and CA bar is also calculated. So this is AB plus CA bar. So AB and CA bar means add, if anyone is there, then we will give 1. So it is 0. You can see in this 1 is here. You can see both are 0. In this 1 is present. In this also it is 0. In this also it is 0. In this 1 is here, and you can see in this also 1 is here. So 1 1. Now you can match it. This all the rows are now matching. So this is left side and this is right hand side. You can see this is equal to this. So this is equal to this with the help of this truth table. So how we will solve these equations? You have to remember the formation of truth table, how we are doing this, and or logic. It is very much important for you. Now students, next question. State the principle of duality in Boolean algebra and give the dual of the Boolean expression. So as we have discussed dual, so in dual what is the logic? Very simple it is. If plus is there, then dot you have to replace. If 1 is there, then 0 you will write. If 0 is there, then you will replace it by 1. So this is the duality. A question is given, x plus y dot x bar plus z bar, x bar plus z bar dot y plus z. So we have to find the dual of this equation. So very easy it is. This is plus, so you will write x dot y. You can see it is dot, so you will write plus. You can see this is plus, you will not do anything with this bar, remember this point. So you will write x bar dot z bar plus, this dot you will replace it by plus, and then y dot z. So this is the dual of this equation. Like this you have to solve it. Now next question. Prove the idempotence law of Boolean algebra with the help of truth table. So it will come, it may come like this also. Prove idempotence law. Like these questions may come in your exam. Prove idempotence law with the help of truth table, and at this point you have to remember that what was it, what is the law. So if you forget the law, x plus y is what, then you will separate, definitely you will not be able to solve this. So x plus x is equal to x, or x into x is equal to x. So these are the two laws which is in idempotence law. So if x, you can see the equation. So this is the first equation, this is the second equation. In this you have to remember that how many variables are present in this. X, 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 only one variable. One variable means how many input conditions will be there. 2 means 0 and 1, again 0 and 1. So if you are adding x plus x, so in our logic what is the condition? If any one is there, then you have to give 1. So it is 0, it is 1. So you can see x plus x is also equal to x plus x is also equal to x only. This is also 0 1, this is also 0 1. So that's why we are saying x plus x is equal to x. This is the first idempotence law. Second is your x, x, x. You can see only one single variable is there. So 0 and 1, 0 and 1 will be the condition. And when you will multiply, in multiply what is the logic? In AND logic, if any 0 is there, then you have to give 0. So it is 0 if it is 1. So you can see this is also same of this. Likewise these two laws are proved. So this was the law, and you have to remember that what is the law. If it is coming that prove absorption law, at that time you have to remember what was absorption law. Now students, this question as it is given, as in yesterday's video also I have discussed that this kind of question may come in your exam as well. This is AND gate, input is A bar and B bar. This is OR gate, one more AND gate, and its input is C and D. So in this, derive the Boolean expression. What will be the answer? Finally what you will get here. So this is what how you will start to solve it. What should be your approach? You will start from the very left side of the given diagram. So what will come here? It will give you multiply, means A bar dot B bar will come here. What will come here? C dot D will come here. What is the work of this OR gate? This is AND, this is OR. This is used to add. So this will give you A bar B bar plus C D. This will be the answer of this question. So if any question is coming that derive the equation of the given circuit, then you have to start it from the very left side of the circuit. You have to start it from this side, then you will move that side, then you will get the answer. Now the second question is, what is the function, what function is implemented by the shown circuit? Now in this, the diagram is given here. This is AND gate. You can easily understand this is NAND gate. NAND gate means it will perform AND, and whatever the answer will come, this will reverse it. This is called NAND gate. Its input is X and Y and Z. Now, and you have 4 options also. Number A, X bar Y bar plus Z. B, X dash plus Y dash Z. C, X dash Y dash Z. And D, X dash plus Y dash plus Z. So, and E is also there, none. So what answer will come in this equation when you will solve. So you have to start it from the very left side. What will come here? It will multiply means x y, and it will inverse, so it will give you bar on both. Now what is the use of this? This will add the variables, so x y bar plus z. This will add the variables x, but it is not present there. You can see x bar y bar plus z, or this is not the separate bar, means this bar is on both the x and y. This is not the separate bar, so this is not true. So what you will do? You have to use here De Morgan's theorem. What De Morgan's theorem says? Already we know that two De Morgan's theorems are there, and first we will use the De Morgan theorem for multiplication these variables, and it will be like this. Our answer is x y plus z. De Morgan theorem says if bar is present on both the variables, so it will be x bar plus y bar plus z. So I have just segregated these variables with the help of De Morgan's theorem, and this is present also in answer. X bar y bar plus z, you can see this D, x bar y bar plus z. You are writing bar like this, or if the bar is like this, both are same. So this is the answer, and this is the method by which you will give the answer. If you are calculating the answer, and if it is not in option, don't point the none option directly. You have to solve it. You have to reduce the equation with the help of De Morgan's theorem or with any other law. Then you have to find it. If it is present, then you have to give the answer. Now like the same, one more question. What function is implementing the circuit shown? So this is the circuit, and they are asking the function. So you know this is NOR gate, this is OR, and this is NOT. So it will add and it will reverse. This is NOR gate. This is X and Y, and then one Z is also there, and in Z this is AND gate. Now there are certain options are also given to think. A, x plus y plus z, then B, x plus y plus z bar, C, x dash y dash z, D, x dash plus y dash plus z dash, and E, none. Now start solving this equation. So first you have to start it from the left hand side, very left hand side of this. So what this OR will give you? This will give you x plus y, and what this will give you? This will give you the bar on it. Okay, then after this and this z will go here, so this will give you the multiplication of this and this. So x plus y whole bar into z whole bar, this will give the whole bar. So how you will solve this equation? Now this is not present in this, so simply you can, if you are not thinking, then you can tick on this none option, but this is not true, so you have to solve it. X plus y bar z. Now start solving it from the inner portion. X plus y, you can see here again you will use De Morgan's theorem. So De Morgan theorem in plus section, it is saying that if plus is there with whole bar, then you have to use the separate bar in multiplication symbol. So x bar dot y bar into z whole bar. Got this? I have done this with only inner portion, x bar, y bar, and then z is separate, so leave it separate. Only inner bracket I have solved with inner bar I have solved this. So this is done by the De Morgan's theorem. Then after this is multiply, this is one portion and this is the second portion, this is first, this is second. So we will apply the De Morgan's theorem again with this multiply. You can see this is 1, this is 2, this is 1 and this is 2. So in this we will apply the De Morgan's theorem of multiplication. So in multiplication what it says, that x dot y whole bar will come plus z bar will come. This is very easy. We have not applied De Morgan's theorem here, we have applied De Morgan's theorem on whole, and this is the multiplication. So in multiplication what De Morgan's theorem says, it will be converted in plus and bar will be on both, this part also, that part also. This is very easy. Now only on this we will apply the De Morgan's theorem of multiplication. What it says, that x bar plus y bar, it is already present, so on the top it is a bar, so one more bar will come, plus z bar. This is clear, I hope. Now you know this, if two bars are there then bar will be cancelled. So it is x plus y plus z bar, and you can find it, x plus y plus z bar, it is here, x plus y plus z bar. So like this you have to find the answer. You will not write directly none, you have to solve it, and after solving also you will get the answer. Now the last question. One OR logic it is given. In this x and y one more NOR is given. In this it is z, one more it is given, and in this it is y. So what will be the output in this case? And a few options are also given, like a x z bar plus y, b x z plus y, c x dash z plus y dash, d x dash y dash plus y dash z dash, e x dash y dash plus y dash z, and one more it is given, none. So first you have to solve. So what it will give you here, it will give you x plus y bar, then what it will give you here, x plus y bar plus z whole bar, and what it will give you here, x plus y bar plus z bar plus y whole bar. This will give you here. Now in this case you have to solve this equation because this is not present in the answer directly. So x plus y bar plus z whole bar plus y whole bar. Very simple. You have to just maintain the blocks. First thing, this is the first block, this is the second block, and this is the third one. Now you will start from the inner portion. in this inner portion you have to use the De Morgan's law of plus. So De Morgan's theorem of plus says that x I am writing slightly downside, x bar into y bar. Your bar will be separated and it will be in multiply form, plus z and whole bar plus y then whole bar. Then after you have to use the De Morgan's theorem for this value. You can see this is the first value, this is the second value. I am solving this second bar. So in this x bar y bar I will not do anything, into z bar, and on this also bar will come. This bar will be segregated, inner one, and this plus will be converted in multiply. This will be x bar dot y bar and then z bar, and then whole bar is also present for y. Then after this you can see this can be solved with the help of De Morgan's theorem. So this is x bar bar plus y bar bar into z bar plus y and whole bar. So we have just removed the inner bar. Now you can solve it. So if two bars are present, then you can easily understand that bar will be removed. So it is x plus y plus x plus y into z bar plus y whole bar. I am solving it here. Now this you have to solve for the full function. Now this is your first function and this is your second function. So this part and this part. So in this part you have to solve it for full function. So you will write it x plus y into z bar whole bar into y bar. Why I have written this? Because you can easily understand this, that if plus is removed by dot multiply. Now solve this. This is the dot. So again you will use De Morgan's theorem to convert it in plus. Now x plus y bar plus z bar and bar into y bar. In this you can see this 2 bar will be removed. So this here also you can apply De Morgan's theorem. So x bar into y bar plus z, 2 bars will be removed, dot y bar. This is the equation. Now you can see this is the one function and this is the separate function. So this will be multiplied by both of the variables. So x bar y bar plus z y bar. Now if 2 bars are there, then you will replace it with a single bar. 2 bars means it will give the value of single bar. So x bar y bar plus y bar z. This is the answer. You can see x bar y bar z. It is present here. You can see x bar y bar z, x bar y bar z. So like this you have to solve the equations and you have to find the answer in the given. Don't click on directly none option. You have to solve it with the De Morgan's theorem and you have to find the answer. Now thank you students. This lesson Boolean logic is completely over. I have discussed questions and answers also. I will give you notes as well. And from tomorrow onwards, insight into Python execution means theoretical lesson it is. I will start. Thank you.